Okay, so continuing on with rem graph. Let's practice really quick graphing another set of complex numbers. I recorded example 1. And I will just do an example of it today, but it's the first example today. So, on the same page notes that you were doing last time. Example 1. Graph each complex number. The one I want you to graph is 5 minus I. So we can draw a complex plane, which normally would be x and y axes, and what we can say the x-axis represents. The real, would you put in it? This is the normal, the old school y-axis representing. It's not y anymore. It's imaginary, so you can just put imagine. Now the real axis counts by their numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. But the imaginary axis doesn't count by 1, 2, 3, 4, 5. What does it count by? 1i, 2i, 3i. So this is 1i, 2i, 3i, 4i, 5i, etc. Same going down. 1, 2, 3, 4, negative 5i. We need to have an I there because it's the imaginary axis. Okay, just like we're graphing our other word pairs, the first number is your horizontal movement, the second number is your vertical movement. So I want you to try to find where 5 minus I would be. And plot a graph, and then turn it over and see if you can put it in the same spot. 5 minus I. The first number is your horizontal movement. The second number is your vertical movement. And then check your answers if you guys agree. That was brilliant this 2 days ago. Good option. Yeah. Whatever. You guys left me out of lunch classes to get their chocolate because they had that many things from the stuff. It's from Interlock in Switzerland. Oh, I do have those. You're bringing it in the class. It's on my schedule, the paragliding videos to show them. Rachel, tell us this in here. There's Rachel, there she is. I don't know. What are you down there for? Yeah, that's pretty good. There's that's this. Okay. So, let's see. Who can describe me where we should plot the point? 5 minus I. 5 minus I. Where should we put it? Yeah. Yes. Okay, how do I move from the origin? I go minus 5. Right, left side, then. Right, 5. And then? Down 1. Down 1. That's really one there. So that's negative I. Okay, so that would be the point 5 minus I. Okay, let's try another example 2. Let's put it right next door. Graph. And we're going to be using these next two examples, so I hope you have them on your paper. Graph, negative 3, negative 2i. I want you to do a new graph, though. A new graph with a real axis. You have to label. Especially important with the complex plane. So when you've got labels, and I don't know that you're graphing in the complex plane. I think you're graphing in the rectangular coordinate system. So I need to label real, I need to label imaginary, and then I need to know what I'm counting by. 5, 1, 2, 3, 4, negative 5. And what's really important on the y-axis is 2, 3, 4. What should I label this? 5. I. If you just put 5, 5, but I think you're in the rectangular coordinate system, which is not correct. You're in the imaginary axis here, negative 5i. So find a place for negative 3 minus 2i. Right? Get alignments off, so I'm going to fix that really quick. Who wants to come get on the board? Okay, here. Oh, sorry. She's so quiet, and after she's done, she's like, I'm done. Do you agree? Or can you disagree? This must have turned up too high. Pretty nice and light, so people can see it. Okay, step to the side, so everyone see. Thumbs up, agree. Thumbs down, disagree. So don't buy it, and everyone see. That's what you think. Yeah, I agree, excellent. And you go left 3, down 2y. Perfect. Okay, now, thank you. Now we're going to learn a new concept called the absolute value of a complex number. What's the absolute value of 4? 4. What's the absolute value of negative 4? Why are they both positive 4? Okay, the definition of absolute value is distance away from 0. So when we're on a two-dimensional coordinate system, it's the distance away from the origin, because this is the origin 0, 0. Okay, so the distance away from 0 actually comes from, when we're in two dimensions, comes from the Pythagorean theorem. Okay, back to example 1. If I connect from the origin, let's make it big. If I connect from the origin down to my point, I have a diagonal, right? Now, if I just like slope, do rise and run, it actually with that diagonal creates a right triangle, right? That's supposed to be a square. Okay, a right triangle. We can find a hypotenuse of a right triangle with what? Pythagorean theorem. That's just mystery questions. What's the Pythagorean theorem? A squared equals, okay, now C is the hypotenuse, right? This is from last year. How do we get C by itself? Square root. Square root, because the inverse of, the inverse of squaring is square root. So I get square root. A squared plus B squared equals C, correct? When you take the square root, what you're actually finding is the distance from the origin to that point. So that is actually the distance formula. And so when we're talking about the absolute value of A plus BI, right? A plus BI is a complex number. A real piece plus an imaginary piece, that's the standard form. Yes, please. All it is the distance formula. The absolute value of A plus BI is just the square root of A squared plus B, not BI, just B squared. A squared plus B squared. What is this? But the Pythagorean theorem solves the hypotenuse. Yep, and make sure the bars are nice and tall so you can visual everyone. So you can actually see that it's absolute value. So for our next example 3, we're trying to find the absolute value of that problem from number 1, which was 5 minus I. The absolute value, meaning the distance from the origin of this point right here, is the square root of, I have in the airplanes, what is the number for 5? Is it 8? I guess that's about 5, right? Now get the given one, and we'll square that. What's the number for B? Wrong. Did you have it? Negative 1. It's not the I, it's the DI. I is just multiplying to B. So in front of the I, the coefficient is -1. So E is our A, which is our real piece, and B is the coefficient of the imaginary piece. So now we just simplify. X goes first, y squared is 25, -1 squared is 1. Positive 1. You have a question? Okay, let me just hold on to it, please. And then 25 plus 1 is the square root of 26. Before you say that this is your answer, meaning you have the value of 5 minus I, before you say that's your answer, you have to check and see, does it break down, which is the simplest form. So I think these are two numbers that multiply to 26 to help us break down the square root. 13 times 2, okay? Does 13 break down further? Why not? It's prime. Can you hear with us? Does 2 break down further? No, because it's prime. Did you match? Because it was square root, and we can a pair of 2 to pull out and match. No, so nothing matches, so I can't pull anything out. So my answer is that's the value of 5 minus I is root 26. Okay? And all it is just finding the distance from it. We're going to do the same thing with the 1 and the 2. So when we're finding the absolute value of this point, we're actually finding its distance from what point? From 0, 0. And it creates the right triangle, right? So right here we're going to put example 4. And we have the value of that same point, -3 minus 2i. So it's the square root of a squared plus b squared. So here, what is a? From the complex number, please don't say that loud, just hold up in the air. Here, what is a? Good. Back row. Fifth row down to Allison. What is a? -3. So put that in parentheses. It's important when you square, it's too big. When you square a negative, you need to put in parentheses. Plus, here's the air, what is b? Good. Because that's compared here, right? A squared plus b squared. That's good. Negative, is it -2i? Or is it just -2? It's just -2, just the number. So it's plus -2 squared. And then we simplify. -3 squared, when we square it should be a positive. It's 9 plus -2 squared. 4, so we get the square root of 13. Okay, let's see if it breaks down. Well, let's see, check this. Two numbers that multiply to 13 to help us break it down. 1 and 13. Anything else? No, that's not. It's prime, so we can't break it down. So that's our answer. The absolute value of -3 minus 2i is the square root of 13. That's called an exact answer. Don't type it on your calculator and get this big long decimal unless the directions say round the decimal. The directions don't say round the decimal. We have to have the exact form, which is square root of 13. Any questions on that? Just Pythagorean theorem, a squared plus b squared, and then square root of the thing. Okay, let's then do, learn how to perform operations on them. We're going to learn how to add and subtract complex numbers, but you actually already know how to do this. Example 5. 7 minus 2i plus -3 plus I. Okay, we have two complex numbers. This one's a complex. Can you see the middle piece and the imaginary piece? in parentheses here in complex, can you see the real piece and the imaginary piece? So you have two complex numbers being added. If I had never taught you about complex numbers, how would you add these? What would you do? You should have to do the multiplication. What does anyone else do, John? How do I know which one's not the other? Common sense? Okay. What common sense? What's that phrase you learned since like elementary? Caitlin? Right terms? What's that this way? Combine right terms. Here you go, to this way. We're just going to combine the right terms. The real piece and the real piece are like terms, right? So 7 and a minus 3 makes 4. It gives us a real number. A real number plus a real number is a real number. What's our other set of like terms? The imaginaries? Yeah. So negative 2 ice creams plus 1 ice cream. Negative 1 ice cream. You can write the 1, but you can also add the minus I. And so that is our answer. It's in standard form, which is the real piece has to come first, then the imaginary piece. Oops, I must have had this wrong. Okay, so, how do you write this one? Throw in a number, go loud. Oh, it's too many numbers. Okay. 4 minus 12i plus 7 one more. Plus 5i. Okay, that's not please. Make sure you answer the standard form. In this case, standard form means the real piece with no variable plus the imaginary piece that has the I. The real piece has to be written first. Imaginary piece has to be written second. And when you're done, your name comes down, compare it all to the viewer, and so we have to see. Okay, we've got them now, but we know the real plus the real. There's a few. We'll add the two measures today. Good. Let's do this one again. Negative 12 plus 5. Yeah, and negative 12 plus 6 is that. So we're close to negative 12 plus 5. Think of 12 minus 5. What's 12 minus 5? 7, so it'll be minus 7, because it's negative 12 plus 7. Okay, Allie, what you get? Everybody else is 3, 2, 1. What you get? Oh, I can't hear because you're still talking. Please be quiet. Okay. What was from down in green? It's green. Yeah, excellent. Because the rails are 4 plus 7 is 11. That makes sense? 11, yeah. And negative 12 plus 5 is negative 7. That will be the i's. Okay, let's try a subtraction one. Example 7. 1 plus 5i minus 3 minus 2i. Notice I put all of the complex numbers in parentheses because we're not just minusing the 3 over here. We're minusing the whole complex number 3 minus 2i. As you never known about imaginary numbers or complex numbers, you should still know how to do this. But what's the first step? This one has an extra step, yeah? We have to change something. There isn't anything else we change positive. There's something else that needs to be changed. Yeah, check. True? Why doesn't it even change negative 10? And why do we have to put an instead of change this negative to positive? Okay, then add the subtraction and everything, what's that process called? Distributive property. So this complex number now is negative 3 plus 2i. Because when you times by negative, or you subtract, each term the sign is going to change. Okay, now can you add them? Okay, go ahead and add them. You can probably do that in 5 seconds. I'm going to finish lots of time. Guess we're on time for videos. Sweet. What? Yeah, homework time. There's plenty of time. We have like 50 minutes, and we have one last thing to learn, just multiplying, which is, you already know how to do that. Okay, that's the answer. So what else talk to you today? Billy. Negative 2 plus, you said 7? 9? Thumbs up, thumbs down. You agree? Disagree? I think Jim's pretty good. I agree with that. Okay, moving on. So actually, let's write the steps really quick. If we're adding and subtracting, the first thing you always have to check is sometimes you have to distribute. That happens with subtraction. So step 1 is to distribute if necessary. Okay? With addition, it's not necessary to distribute. But with subtraction, between the two complex numbers, it is necessary. Okay, then step 2, we add what piece first? Add the reals. Then we add non-reals, what they're called, imaginaries. And then you just need to make sure your answer is in standard form. Standard form has A plus BI, or real plus an imaginary. Okay? It's really not too much different than our normal add and subtract by terms. The only difference I think is the order at the end of your answer. The real part first and then the imaginary part second. Any questions on add and subtract? Learn how to multiply complex numbers. The good news is we don't need to learn how to divide because that gets a little complicated and it goes on forever, so we're not going to learn it. Okay? Multiplying complex numbers, which you probably already know how to do this. There's just one detail we need to make sure is fixed before our answer is written. So our first one is 7i times 3i. 7i is actually a complex number. What's the real piece added to 7i right here? Because it's going to be 1 plus 7i. What's in front of the 7i? What's the real piece in front of it? What? Oh. 0. Good. Isn't 0 plus 7i the same thing as 7i? So this is technically, even though you don't see the real piece, it's technically a complex number because it's a real piece of 0, and the imaginary piece is 7i. Is this one a complex number? What's the real piece on 3i? Oh, that's the imaginary piece. The imaginary piece is 3i. What's the real part? 0. 0 plus 3i is the complex number, which simplified is just 3i. Because writing the 0 is just kind of redundant. Normally, Jason, when we multiply these 7i times 3i, what would you normally tell me the answer is? 21i squared. 21i squared. We already know how to do that, right? There's just one detail that we have at number 4. Remember I told you to memorize 2 things? The square root of negative 1 is what? 1i, or just I. What is I squared? Negative 1 I squared is actually a real number. So this is really 21 times negative 1, which is negative 21. You can never, ever, ever leave an I squared in your answer. Or any i's to the even power. Because I squared is actually a real number. So that's interesting. An imaginary number times an imaginary number is not imaginary. It is real. A negative times a negative is a positive, and a negative is an I. I've never done this with my piece, but imaginary times imaginary is not imaginary. It is real. The I squared, which is a real number, negative 1. Okay, let's try number 1, and we'll write down the steps. The process is very similar to what you're used to, because I can remember this extra step of changing the I squared to a negative 1. Okay, last problem. 2 minus 3i, the complex number 2 minus 3i, times the complex number 4 plus 5i. You're asked to simplify that. How would you normally go about simplifying that? Yeah, and how would you normally go about simplifying, which means timesing those? Come on. 2 times 4. Anything else? I want to do it on yet. We're eventually do that. What? 2 times 4. Come on, I'll do something else with the 2. 2 times 5i. What's this property we're doing? It's in property. So we need to do a double distribution. Yes. Okay, Gavin, what is 2 times 4? 8. And what is 2 times 5i? That's 10i. Go ahead, read yourself. A to B. What else needs to be done? Good. Negative 3i. Let's figure that in. Okay. Operating what is negative 3i times the 4? Good. Negative 12i. And then the last one. Negative 3i times 5i. Guess what's that going to be? Negative 3i times 5i. And then I times an I goes I times I did the negative 15, but I times I goes like x times x. So it's squared. Hey, what would you do next? Combine like terms. We have like terms here and here, right? So 10 ice creams minus 12 ice creams. There are 2 ice creams minus 15 I squared. What else can be done that we have not normally done before until today? So change the I squared to negative 1. 8 minus 2i minus 15. Focus on 15 minus 1. Whenever you're inputting, you should put parentheses because it's negative 15 times negative 1. Yeah? I squared. I squared is negative 1. So whenever I squared, which comes from I times I, you have to convert it to negative 1. Okay? Wait here, we can simplify this, right? Negative 15 times negative 1, Riley, what would that be? Negative 15 times negative 1. Good. Positive 15. So I'll just change that to plus, get rid of that box. Plus 15. Sebastian, what else needs to be done? We have 8 minus 2i plus 15. Is there anything there that I can simplify? to right terms. 15 and 8. Those are the real pieces, right? 15 plus 8 is 23, and then an imaginary piece minus 2i. It's in the right order because we have the real plus the imaginary piece. It's in the right order. So it's pretty much the same problem you already know, just we have a new step, which is changing all I squareds to a negative 1. So first step is distribute. As normal, right? I'm going to distribute on this step before I combine, just do this step. Before I combine my terms, I like to change my I squared to a negative 1. That way I have to combine the terms once. We end up having to combine the terms at 2 different points. So I would first actually change the I squared to a negative 1. And then combine my terms, and then you're good to go. What? Oh, change. Sorry. I'm very fast with my hands sometimes. And make sure your answer is always in the right form, A plus BI. Okay? Questions? Don't leave any I squared in your answer. On your homework, I'm going to give you 2 reminders. On your homework, 2 reminders. One is square root of negative 9 times square root of negative 49. How do we multiply 2 radicals that have the same index? Just like fractions, when we multiply fractions, do we have to have a common denominator when we multiply fractions? Do we multiply? No, we only have to try to get a common denominator. So then we just multiply them together. Same thing with the radicals. So this just becomes square root of negative 9 times negative 49. And this becomes, I don't want you to go to plus or minus 3i, plus or minus 7i. That's all we're trying to do here. So let me calculate. What is negative 9 times negative 49? 441? And it's positive, which means we can take the square root of it. How do you take the square root of that, please? Let's come out next to you. 21. And it's only the positive version. Usually we do plus and minus when we apply the square root ourselves. The square root is already written down for you. We've already chosen the sign, which in this case this is a positive because there's no negative. Okay, one other one. What is negative 1 times negative 16? Let's push them together. What do I put underneath? It'll be positive 16, right? Because negative 1 times negative 16, which is positive 16. That's the square root of positive 16. Just 4. So these come straight from problems on your homework. So remember how to multiply radicals together, because that'll be part of the complex number. Okay, so you already have your assignment, page 187, 128, 15, 16, 22, 32. I will show you quick videos from my trip. And then the rest of the time is yours to work, as long as you're actually working.